Hello, class. Continuing in section 3.3, we're going to talk about the idea of where a function would be increasing and where the function would be decreasing. And we typically define that on the values of the x, that when you plug in the equation, y goes up, that means we're increasing. So that implies a positive slope. And if you plug in a value of x and y comes down, that means that we will be decreasing, and we're going to talk about that as a negative slope. And that's really the concept of increasing and decreasing. We also have the concept of constant, and that means the slope is zero. And that looks like a horizontal line, which implies that the slope is zero. Remember, a vertical line is the slope is undefined. And so we're not going to talk about that in this case because that's not a function as well. Of course, we have to make it a little bit more complicated and have a very mathematically fancy definition of increase and decrease. And so here is the fancy definition for increasing. And we always talk about it on an open interval. And what we mean by that is the two endpoints aren't included. And you'll get a better feel for that when you get into calculus because these endpoints typically are places where the slope might end up being zero. So we are just going to exclude that in the definition. But you can see on this slide here, as you can see, as the x values get plugged in and they go up, the y values go up with it, right? So this would be a positive slope. And that's what we mean by increasing. And the same thing in decreasing is this idea of a negative slope, whereas the x values are going up, the y values are coming down. So it's opposite, right? If the x values were going down, that would mean the y values would be going up. So that's the idea of a negative slope, or the values decreasing. We also have this idea of constant. And that means as you plug in x values, the y value stays exactly the same. And so that would be a slope of zero, and that would imply that we have a constant. So what we're going to do is we're going to take a look at this graph and decide where in the graph the values are increasing, where are they decreasing, and where are they the constant. And we'll also review range and domain with regard to this graph as well. So with that, I took that graph and did a reasonably bad sketch here on the whiteboard so I could talk about it and walk through this. So the idea is, where is it increasing, decreasing, and a constant? Well, the constant's usually the easiest one because you're looking for a horizontal line. And you can see that the value is a constant. And basically you want to define that over what x values, the domain aspect of it. So it starts at x equals 0. We'll always have an open interval. And it goes all the way to x equals 3. So that's where on this graph is constant. So the next question would be, where on this graph is it, say, increasing? So that would be the concept of where do you see a positive slope when x is increasing, y is increasing. So that would start down here at x equals -4, and we're increasing all the way till we get to x equals 0. You can see we're continuing to go up. As x gets bigger, y gets bigger with it, right? So it goes in the same direction. So that would start at -4, and that would go all the way to 0. So where is it decreasing? Well, there's a couple places, right? The first place would be from -6 down to -4, because you could see as the x value is going up, right, the y value is coming down, and we have a negative slope right there. So one of them would be -6 and -4. See any other place where it's decreasing? And the answer is yes, from this part of the line segment over here. So at x equals 3 to x equals 6, those values are also decreasing. So again, the idea of doing this, 100% need to look at a graph. With that, just looking at the equation is very difficult to do that unless the equation is really simple, like linear equation or quadratic, right? But besides that, it's really important to take a look at the graph. So the other thing, just to point out, we have two x-intercepts, right? -6, 0, -2, 0. We have one y-intercept, 0, 4, what we talked about. So let's again review what would be the domain of this graph. So what is the smallest value of x? That would be -6. And since that's a dot, that means it's included. So it'd be -6. And what's the largest value of x? It would be +6. And you can see we also have a dot there. So the domain would be -6 to +6. What is the range? So what is the smallest value of y? It looks like it's -2, and there's a dot there. So that again would be a bracket, -2. And the biggest value of y would be right here, and it occurs multiple times, but that's okay. The biggest value is 4, and again is included in that aspect. So we put a bracket there as well. So this is the concept of increasing and decreasing functions and aspects of trying to figure that out by looking at the graph. Again, concept and strategy is an increasing, you're looking for a positive slope. Decreasing, you're looking for a negative slope. And a constant part of it, you're looking for a slope of 0. And that would be looking at a horizontal line as part of the graph. Next, we're going to talk about local and absolute maxes and mins of functions.